Welcome back to Migration 2020. This morning we're getting it kicked off with Eric Hinson, President and CEO of Simcom International.
Hi, my name is Eric Hinson, and I'm the President and CEO of Simcom Aviation Training. I'm pleased to be with you here today virtually for the first virtual Redbird migration. Charlie is a good friend, and he asked me if I could speak at this year's migration. I asked him if there was a particular topic he wanted me to speak on, and he said, really, it's up to you. You can talk about anything you'd like to talk about. So I thought about that, and I thought, my first thought was maybe I'll share with you kind of what's going on here at Simcom. We've had a lot of changes recently, a lot of exciting new things coming. Then I thought maybe, what it's like to manage through a pandemic. I know everybody's having to do that. This is mostly, I think, flight instructors, and then I thought, maybe I could share some of the great tips I've learned from some of my favorite flight instructors over 40 plus years of flying. And then it occurred to me that when people learn about my background, and I flew first as a civil pilot and later I flew in the Navy for 11 years, predominantly tactical aircraft off of aircraft carriers, inevitably they want to know, what was it like to land on an aircraft carrier? So rather than bore you with business discussions or talk to you yet again about the pandemic. I'm sure we're all tired of hearing about the COVID-19 pandemic. Instead, what I do is spend some time walking you through my experiences as I went through naval aviation training. I think there's some universal lessons that can be taken away from there. There's probably some interesting stories I can share as well. So I look forward to spending a little bit of time with you. Hope you find it enjoyable. And as I said before, hopefully we'll all have an opportunity to get together next year. From as early as I can remember, I was fascinated with airplanes and aviation. My father also flew in the Navy and then spent the entire rest of his career in aviation, both on the commercial as well as on the business aviation side. When I was 17, I got my private pilot's license, but I always knew, even back then, that my goal was to go fly in the Navy. So while I was in college, they had a program in the Navy called AVROC, which basically guaranteed you a seat in flight school. So after graduating from college, I went down to Pensacola, Florida, where I started a 16-week aviation officer candidate school. Some of you may have seen the movie Officer and a Gentleman, so you know that we had Marine drill instructors down at AOCS in Pensacola. And I think truly the only reason those Marine drill instructors were there were to make our life as miserable as they possibly could. The Navy was going to invest a lot of money in us over the ensuing years as we learned to become naval aviators. And I think AOCS served not only as a school where they taught us how to become officers and some of the initial aviation training that we received, but it was also very candidly a weeding out process. I mean, if you didn't really, have a vested interest in wanting to become a naval aviator, very candidly, you wouldn't really put up with what these Marine drill instructors would put you through. The first week you're there, you're in what's called an indoctrination battalion, and it's quite an eye opener that first morning at 4 in the morning when the drill instructors start throwing trash cans down the hallway and yell at you to get out online, and you get out of your rooms and you're immediately doing physical training with these drill instructors just yelling and screaming at you because apparently you can't do anything correctly. But you learn over time that there's a method to their madness, and not only are they teaching you how to become officers, but they're trying to create a stressful environment because you have to perform as a naval aviator in what can be sometimes a very stressful environment. So it serves as a litmus test to see if this is something that you really are interested in doing, and that if you can thrive in sort of that type of environment. So the course is 16 weeks long. The first 8 weeks are really focused on the military training portion of it, and then you get into some of the other things that you're going to need later on in your career, like water survival. I remember we had to swim a mile with a flight suit on. For those who were not as comfortable in water, that sometimes proved to be pretty challenging, as did the helicopter dunker. That's that device that would drop in the water, flip upside down, and it's like the inside of a helicopter, and you would be blindfolded and have to figure out how to get out of there. And if you couldn't get out there, at least were safety divers to get you out. So after the 16 weeks, you were commissioned as an officer in the Navy. It's a great day when you go through the parade ground and you're able to salute your drill instructor, or actually I should say he gets to salute you now. And then the next phase is to go on to primary flight training. So I've completed AOCS, and now I'm ready to start flight training. And this is when I learned that the Navy is a big, giant bureaucracy, and sometimes, gets a little too far out in front of itself. They weren't ready for us in primary flight training when I completed AOCS. So I got assigned to Washington, D.C. for almost 5 months, where I learned how to shuffle paperwork, another important skill set that the Navy teaches you, and waited for my flight class to begin. So after 5 months, I moved back down to Pensacola, Florida, where I started primary flight training. The aircraft we used back then for primary training was the T-34C Mentor. This was a single-engine turboprop aircraft built by Beechcraft with tandem seating. It was actually a barren wing that they used to build the Mentor, and it was a fun airplane to fly, great primary trainer. So the training was actually broken up into phases, and some of those phases I think would be very familiar to civilian pilots, not much different than the way you learned as a civilian. All the basics in what we call the familiarization stage, where you learn how to take off, how to land. You learn the basics around balanced flight and all the things that you would be familiar with. There are a couple places, though, that are a little different. First off, the Navy very early on in your training, even in your early primary training, has a strong emphasis on instrument flying. So even in primary flight training, we did a lot of simulator work. I think we flew about 20 hours in the simulator back then. Now, these were not sophisticated simulators. They were fixed. They had no motion and they had no visual system. But they replicated the T-34C, and they had all the instrumentation, and you learned how to fly both what we call basic instrument flight. So this is just learning how to fly using an artificial horizon and your turn needle and compasses and all the basics associated with controlled flight on instruments. And then we also learned radio instruments, and for us that was TACANs, which was the military equivalent of a VOR, and of course this was pre-GPS days. Another interesting difference between Navy and civil flying was on that instrument side, we really didn't have any ILSs of any kind. Later on, when you get to the fleet, we had what was called an ACLS, which was the equivalent of an ILS at the aircraft carrier, but that's on a completely different frequency than ILSs. So even when I got to F-18s, we did not actually have an ILS in the aircraft. So we did what were called ground-controlled approaches, GCAs, and this is where a controller is essentially serving as your your glide slope. He's providing glide slope information as well as azimuth and lineup information. So we would learn GCAs, we would learn TACAN approaches and the like during these RI stages. The other part of the training that was different was the formation flying. Obviously, as you move through the training process, and then once you get to the fleet, formation flying is a very integral part of how you fly aircraft in the military. So formation flight starts early. in primary flight training and then progresses once you get into the later stages of training. And then perhaps the place where the training is most different is around the landing pattern. And even in primary flight training, we were learning from day one how to fly essentially the pattern, the daytime pattern that we would fly at an aircraft carrier. And where that's notably different than in the civilian world is in the civilian world we fly a square off pattern where you fly a distinct downwind leg, and then you have a base leg, and then you turn to final. In the Navy, the way they teach you how to fly is again the way you're going to do it aboard a ship, and you fly a downwind leg, and then you fly one continuous descending turn 180 degrees. Actually, when you go to the ship, it's 190 degrees because of the offset angle of the angled deck. And you fly that to arrive at this point which we call the groove. And the groove is this cone, if you will, that comes off the end of the runway or the carrier. And you want to arrive at that spot with the right attitude on your aircraft and in that cone. And so there's a tremendous amount of focus, even from your very first landings in primary, on this idea that you fly the pattern correctly to always arrive with the right attitude, right airspeed, and so forth in this cone to fly the groove. The other thing that we emphasized more so later on in intermediate jet and advanced jet training, but it was also emphasized in primary flight training, and that is this idea of angle of attack. And the Navy is very focused on you learning how to fly angle of attack. And there's a lot of good reasons for doing that. But there's one very specific reason that all carrier pilots get so focused on angle of attack. And that's because when you fly aboard a ship, if you think about this for a second, we had a visual reference for landing on a ship. And that visual reference, obviously, we're looking at with our eyes. But our eyes are not co-located where the hook of the aircraft is. So you had an eye path, and then you have the hook path, and they're on two different paths to the ship. What controls the difference between the eye path and the hook path is in fact your angle of attack. So you always want to have the exact same angle of attack so that it's very predictable where your hook's going to be relative to your eyes. And when you're landing aboard a ship, they actually depending on what type of aircraft you're landing in, they dial into the landing system a different adjustment depending on that hook to eye value for various aircraft types. And just to give you an idea of how critical angle of attack control is, as well as glide slope control, when you're at the start position of that groove, which I talked about earlier, to be one single cell on that Fresnel lens system at that point is about 11 feet wide. But because it's obviously a cone, that shrinks as you get closer to the boat. And when you're crossing the ramp, to have that same picture, in other words, one cell, it goes from 11.5 feet down to 1.6 feet. So you're flying in a shrinking cone, and so you have to be incredibly precise with your control of the glide slope of the aircraft, but also with respect to the proper angle of attack so that the hook point is consistent and will hit in the right place in the landing area. If you are low and you're slow, that hook point deviation can be so severe that you can potentially strike the back of the aircraft carrier, either with the hook or even with the entire airplane. So again, there's a lot of focus on control of your angle of attack as well as control of your glide slope. There are a couple of lessons that I took away from primary flight training. The first is precision matters. If you want to be a competent pilot, you need to pay attention to the details. And our instructors really focused on that. For instance, in the landing pattern, which was 600 feet AGL, it was not acceptable to be at 620 feet, nor was it acceptable to be at 580 feet. And that desire to be precise is something that was instilled very early in our flight training. And I think, to this day, it's something I still strive to do, is be as precise as possible when I fly an airplane. The second and somewhat related lesson is that constructive feedback is a good thing. And the Navy provided us with lots of constructive feedback. Everything we did in the Navy was graded, particularly landings. Landings, every landing you ever do on a ship is graded by a landing signal officer. And the reason is because if you're constantly evaluating, then you have something that you're measured by. And as long as you're being measured, you have to live up to an expectation. And that's a really important lesson that I think translates well into the civilian world as well. After completing primary flight training, I was selected for the jet or tactical pipeline. The Navy has 3 pipelines for training. Initially, everybody goes through the same primary flight training. After primary flight training, you're either selected for the helicopter pipeline, the maritime pipeline. That's back then that was going to P3s. Now it's, I think, P8s. Or you were selected for the tactical jet pipeline. The tactical jet pipeline back then had 2 distinct stages in it after primary. You had intermediate jet training, and then you had advanced jet training. And for me, both of those training cycles took place at the Naval Air Station down in Kingsville, Texas. So I packed up, moved from beautiful Pensacola, Florida, to Kingsville, Texas, and I moved in December. And for those of you who may live in South Texas, I apologize for maybe saying some disparaging things here, but as I drove to Kingsville and I went through literally hundreds of miles of plowed under fields, and so I just saw brown dirt everywhere. And of course it's very flat, and it was cold and raining, and I thought, if this isn't the most depressing place on the entire planet, then, it must be pretty close to it. I later learned that it's actually a great place to be based, and in fact, after I got my wings, I ended up doing what's called a surgrad tour. They selectively retain a few students, and I taught advanced jet training there for a year and a half before I went to the fleet. So I spent almost 3 years in Kingsville, and I grew to really enjoy it down there. Anyway, my first impression, though, was not a favorable one. When I went through intermediate jet training, the Navy was using the T2C Buckeye. This was a Rockwell-built, dedicated intermediate jet trainer. It was tandem seating, 2 engines, great airplane, straight wing, great airplane to learn how to fly a jet. The curricula, I actually have it here, so I don't have to do this from memory. It's interesting. It was about 100 total hours of flight time. We had 24 hours of that approximately that were solo. What I didn't recall was how much time we spent in the simulator. There's actually about 44 hours of simulator training. These were a little bit more sophisticated simulators than in primary. Again, no visual system, but they were predominantly used for instrument training, but they did have full motion systems. So we learned basic instruments, again, radio instruments in there, emergency procedures, all those types of things during that training. And then the first phases in the aircraft included, again, basic instrument and radio instrument to complement what you did in the simulator. And then you went into the familiarization stage. And again, many of the things we were doing in those familiarization stages were similar to the things that you learn on the civilian side of training, albeit, of course, in this time in a pressurized jet and with higher air speeds and the ability to load up the airplane to higher Gs and so forth. After completing the familiarization stage and soloing in the T2C. You went on to some other stages that are not as familiar on the civilian side. We really don't learn these things in the normal course of flying. But again, the Navy is not only trying to teach you how to operate an aircraft and safely convey yourself from one point to another, but they're also trying to teach you how to deploy this aircraft as a weapon system. So in order to do that, there's a lot of other skill sets that they have to teach you. And those include what's called operational navigation or low-level flying. Back then, that was done with sectional maps and a compass and airspeeds and dead reckoning. We didn't have GPSs, so you did it that way. We also got into more advanced formation flying, tactical formation flying and the like during intermediate jet training. We had an out-of-control flight module where we would take the T2 up and we would depart it pretty much every conceivable way you can depart an airplane. And again, you're doing that because as you advance in your training, you're going to eventually get to air combat maneuvering, and when you're doing that, you're always flying the airplane at sort of the edge of its flight envelope, and sometimes you exceed that flight envelope and the aircraft stalls and you get into lots of accelerated type stalls and the like. So you had to be very familiar with how to manage an aircraft in those sort of flight regimes. We also had an air-to-air gunnery module. And that was quite colorful and something obviously that's very unique just to military training. And just to give you sort of a little bit of color as to how that works, a T2 would go up and tow a banner behind it, literally like the banners you would see being towed down the beach. And this was the target banner. And there would be 4 T2s in the pattern, and they would basically fly a figure 8 around this banner as the banner was being towed straight and level. And so you would go off what's called a high perch, and you would make a turn back down, descending, and then you would reverse your turn, and then you would track on the banner and try to shoot the banner with the proper deflection. The proper deflection was important because if you were too sucked, meaning you were not enough angles between you and the tow plane, it was possible that you could actually shoot the tow plane while you were shooting the banner. So it was important to have the right deflection. You would come off the banner and then you would turn back up and then reverse back up to the high perch. So you got 4 airplanes going around the pattern like this, and you can imagine that gets pretty confusing, and you have to continually look out for the other aircraft. In fact, after I completed my intermediate jet training and I was in advanced jet training, another group of students were going through, and 2 of the aircraft that were flying in this pattern actually did not see each other. One was coming off the high perch and the other was coming off the banner, and they converged in that middle point and they actually hit each other. The one airplane was not controllable, and the pilot successfully ejected from the aircraft. And the other one, it actually sheared off a portion of the wingtip and the wing, as well as part of his horizontal stabilizer, but the airplane was controllable, and he could actually fly it and recover back at the field. So, real testament actually to the T2. Another story that's interesting about that is, so they've been flying that kind of pattern for decades, and shortly after that, a fleet guy who was flying in F-18s figured out that there's probably a better way to fly that pattern. Rather than have the tow aircraft fly straight and level, why not have the tow aircraft fly in a circle and then put the aircraft that are shooting at the banner at the 4 quadrants and have them each individually track on it, and then way the aircraft never enter the same airspace. That became the new gun pattern, so it just goes to show you that even after doing something one way for decades, if somebody comes up with a better way to do it, the Navy was generally pretty quick to adopt it. The highlight of the intermediate jet training phase, of course, was carrier qualification. This was our first opportunity to land aboard an aircraft carrier. And as I mentioned, from day one in flight training, even in primary, we were learning how to fly the same way, the pattern, and land the same way we were going to land aboard a ship. And so that obviously continued in intermediate jet training. Every time we came back from a flight, whatever fuel we had remaining, we would go into the touch and go pattern and we would bounce, as we called it, and did multiple touch and goes until we got to minimum fuel and then would land the aircraft. And when we did these bounces, we would land in what was known as the carrier box. And this was just simply the outline of the aircraft carrier that's superimposed on the runway, immediately adjacent to the Fresnel lens system, which is the landing system, the same landing system we would use at the ship, and we had them at every Navy tactical airfield. We had that same system so that, again, we could practice the same way we would see it at the ship. The optical landing system used aboard aircraft carriers was actually a British invention. It was a mirror system, and the U.S. Navy adopted that system and then later improved on it with the Fresnel lens system. The Fresnel lens system provides much more precise glide slope information than the original mirror system. That system is comprised of a green set of datum lights. They're horizontal, and then you have a vertical set of white lights that are set at very precise angles. And so as you're flying the glide slope, those source lights will show you whether you're above, on, or below the glide slope. And so that system was used both at the field and at the carrier. And when we were preparing for our first carrier qualification, we did a series of FCLPs, or field carrier landing practice. And during intermediate jet training, we had 10 of those sessions. And all you did was go out and practice with a landing signal officer who would grade each one of your passes as you flew them at the field. And so on each of these FCLP periods, you would get 6 to 8 landings, and so by the time we went to the ship, we had about 60 to 80 touch and goes under our belt, obviously in addition to all the ones we had done previously during our training. But it's a very intense period where you learn how to fly your glide slope very precisely, and that of course prepares you for going to the ship. After completing the FCLP periods, the next step was, of course, carrier qualification, the big day. For us, back then, we had a dedicated aircraft carrier for training. It was the USS Lexington, and it was based in Pensacola. So my class deployed to Pensacola, and then the next morning we flew out to the ship. And you do your first carrier landing solo. There isn't an instructor sitting in the back of the T2. It's you all by yourself, and I think that's understandable. I'm not sure there's any instructor in the world who would be patient enough to sit in the back of an airplane as a student naval aviator is making his first carrier arrestments. So off to the ship we went. The ship generally was 40 to 60 miles off the coast of Pensacola out in the Gulf, and you'd fly out there and the first thing you'd notice is, man, that aircraft carrier looks really small. And even though you've been training for this basically since primary, it's still a bit surprising when you first show up over the ship and you just look at how small that landing area truly is. Anyway, when it's your turn, there's what's called a CV1 arrival, which is for standard VFR flying, which is, of course, the only weather they'll permit you to do your first carrier landings in. And you fly to the ship, and basically at 5 miles you enter a port orbit around the ship, and you're at designated altitudes. And then you're looking down at the ship, and of course our instructors are leading the flight, so they would time when it was appropriate to enter into the break, and you would depart this holding pattern and turn out and back in towards the ship, and you'd come across at 800 feet, and the flight would break about a mile ahead of the ship, so that's just a level 3 to 4G turn to decelerate down to the downwind. And then you flew the same pattern that, again, we'd been flying since primary. And after that, it, pretty much looked the same. The first two approaches you make to the ship are actually touch and goes. So as you come around off of the 90 and you're approaching the groove, you're at about 400 feet. And of course, as we talked about before, you're flying your optimal angle of attack. And if everything worked out right, you'll intercept the Fresnel lens system with the ball somewhere close to the middle. And then you continually work that glide slope and your angle of attack all the way to touchdown. So in my particular case, the first two touch and goes went fine, and I thought, okay, I think this is going to work. And the air boss comes up and tells you to put your hook down. And so now I'm about to make my first arrested landing, and I'm pretty excited about that. So I come back around on my first pass with my hook down, and when you're first learning, you think you're controlling the glide slope pretty well, but later on in your career, you learn that you're really not seeing all the movement that's happening, and it takes a while before you really, truly see all the deviations that you do in your glide slope. And but I think I'm doing a manageable job, and the ball's not moving too far up or down relative to the datum light. But on my first attempt at an arrested landing, nothing happened. I did not catch a wire. The airplane didn't stop, and so what I did was what's called a bolter. Every time we land on an aircraft carrier, we go to full power or military power in the event that we don't arrest, and then you simply go airborne again and you try it again. In my case, though, after I didn't arrest, I thought, man, this must be much harder than I thought it was, because I thought I was in a position where I would catch one of the wires with my hook. After I climbed up, they had one of the instructor pilots join on me, and then they told me that I was supposed to fly directly back to Pensacola, and I had no idea why. I thought, my gosh, this must be, as I said, much harder than I thought, because I thought I was doing a decent job, and now they're going to disqualify me before I even get another attempt to land on the carrier. So I got back to Pensacola, and once I landed, the plane captain came out and he said that he got a briefing from the instructor pilot, and he showed me my tail hook, and I actually have that original tail hook here. And what happened was my tail hook struck on one of the wires at an unusual angle, and it actually chipped. You can see it here. It chipped off a portion of my tail hook. And so this is a T2C tail hook, which I now have as a souvenir. But that was my first attempted landing aboard a ship. Fortunately, I got a new tail hook. I went out to the ship and I got the rest of my landings, and I finally became a carrier qualified aviator. So a little eventful the first time around, but it all worked out. After completing carrier qualification in the T2C, we were on to the next stage, which was advanced jet training. The TA-4J Skyhawk was the aircraft that the Navy used for advanced jet training for a couple of decades, right up until the mid-90s. After that, it was replaced by the T-45 Goshawk. But back then, we were flying the TA-4J. The TA-4J was actually a Vietnam-era combat aircraft, a light attack aircraft that was actually designed by a famous aircraft designer named Ed Heinemann. It was designed to be a very low-cost, highly maneuverable light attack aircraft that could carry a variety of air-to-ground weapons. It also turned out to be a pretty good dogfighter. In fact, it was so good that later on Top Gun adopted the aircraft as an adversary aircraft. It was the same A4 essentially, but it had uprated engines in it. It had an extremely high roll rate. 700 degrees per second was the roll rate in an A4. So it was an impressive airplane, a lot of fun to fly, and in my estimation, the perfect jet to do advanced jet training. At this point, we have about a total of 170 flight hours in our Navy training. We also have a little over 60 hours of simulator time. And looking back on it, I was kind of surprised. I didn't remember spending that much time in simulators. Maybe I tried to block it out, given we were usually in the simulator at 5 o'clock in the morning, and we usually had grumpy instructors who didn't really want to be there, and they were very demanding. Nevertheless, we were building on the knowledge set, obviously, that we were gleaning from both primary and intermediate jet training. And those served as good building blocks, and we continued to build on our instrument proficiency and our general flight proficiency in advanced jet training. The training was broken down in advanced jet training into 12 stages, and aside from those first couple of stages, which looked familiar and were some of the things that as I said, are very typical of what you would see in civilian training. The rest of it, again, was more focused on developing your skills and your ability to use the aircraft as a weapon system. And so, starting with flights, or I should say stages like tactical flight formations, this eventually led into air combat maneuvering. We also had an air-to-ground stage where we learned how to use the aircraft in the bombing pattern as well as the strafing pattern. And then it culminated again with another carrier qualification stage. And at this point now we're taking the A4 Skyhawk to the ship. And the A4 behaved much more like the fleet aircraft that we were eventually going to fly. The T2 approach speeds were in the sort of 100 to 110 knot range. The A4 Skyhawk was more in the 120 knot to 130 knot range, so much more similar to F-18s, A-7s, A-6, and the aircraft that were in the fleet at the time that I went through my training. I think I'm running out of time. But before I close, I wanted to talk about two other topics. One was probably the most fun stage of advanced jet training, which was air combat maneuvering. This is where we're learning how to fight other aircraft. And the other is something we learned in all three stages because it's specific to each aircraft, and that's in the event that you lose your engine, how do you make an emergency landing? And the Navy has a very specific and I think very effective way of teaching that, which I think, again, is something that would be applicable regardless of what aircraft you fly. The air combat maneuvering that we learned in advanced jet training was really more about the basic fighter maneuvers. Later on, when you got to the fleet and you were flying an F-18 or today F-35s, the whole idea was never to get to emerge at all. The idea is to shoot the other aircraft down even beyond visual range. But you needed to know how to fight in the event that you did eventually get to emerge. If none of those advanced weapon systems worked, then you were down to your gun or a close-in weapon system like AIM-9 Sidewinder. And so these basic fighter maneuvers, you're learning how to maneuver your aircraft so that you can put it into a position where you are what's considered offensive and you can shoot the other aircraft down. And so there's building blocks that you go through to learn these basic fighting maneuvers, basic fighter maneuvers. And they start with, I'm not going to spend a lot of time on the details. We could do an entirely different presentation on this. But basically you start with what are called horizontal scissors, and the airplanes are about a mile apart, and you basically are trying to slow your forward vector down of the aircraft and position your aircraft so that you're behind the other aircraft and you can become what would be then offensive. That later turns into something which is called rolling scissors, which is a maneuver where you're doing the same thing. You're trying to get your lift vector, imagine a line coming up right out of the top perpendicular to your wing, and you're trying to put that lift vector behind your adversary. And so again, you're trying to create a position where you create what are called angles, so it allows you to flush your opponent out in front of you and get you in a position where, again, you can be offensive and either shoot missiles at them or guns. It's hard, of course, to do any of this without using your hands, so apologies. Air combat maneuvering is really about energy management. In the Navy, we use these charts called energy maneuvering diagrams, and the diagrams are useful in that they show you sort of the operating envelope of the aircraft, and you, depending on what you're trying to achieve, you can see that there are certain airspeeds and certain G loadings on the aircraft to get you the desired outcome. So for example, if you're trying to sustain the energy on your airplane, in other words, not bleed airspeed, and maximize the rate of turn, there are certain airspeeds where you can do that. If you're trying to maximize the rate of turn that you get, regardless of whether you lose energy on the airplane, there's an optimal speed to start that at. You're going to lose a lot of airspeed in the turn, but it would maximize the rate or the degrees per second that you can turn the nose. So again, depending on what you're trying to accomplish, these energy maneuvering diagrams allow you to understand how your aircraft will perform. So when we go through the training in advanced jet training in ACM, we're learning how to manage that energy package on our aircraft. And the delicate sort of balance that you're trying to deal with is there are times when you want to trade that energy on your aircraft, meaning predominantly airspeed or altitude, to increase your rate or to increase the angles that you're generating with the nose, because you're trying to get your aircraft in a position where you can deploy either guns or missiles to defeat the adversary aircraft. But as you're making those aggressive turns, you're losing energy. And again, you have to be, you have to understand that if you can't get those angles and you get too slow, you're going to immediately put yourself in a defensive position. So learning how to manage that energy is really what you're learning how to do when you're learning about ACM. And I think that idea of understanding energy management and understanding what kind of energy you have on an aircraft not only applies to ACM, but applies in all other phases of flight as well. When I think about some of the commercial accidents where these large airliners land long and overrun the end of the runway, typically it's because they don't understand the amount of energy that they have on the aircraft. They've got way too much energy as they're coming across the approach threshold, and that lack of understanding or awareness of that energy is what ultimately causes the accident. So again, I think it's something that is applicable to any type of flying, is this understanding of what sort of energy do I have on my aircraft. Let me just speak for a moment about forced landings. This is the situation where you lose power in a single engine aircraft and you're required to make a landing, either hopefully at an airport, but if not, then to the field of your choosing. And the Navy, I think the Air Force uses the same technique, teaches a very specific pattern, and we learned it in primary flight training, we learned it in intermediate jet, and we learned it in advanced jet again. And the only thing that really changed were the airspeeds and the altitudes for the pattern that you fly. But the basic pattern is a pattern where you arrive over the intended place that you want to land, perpendicular to the landing direction, and then you fly a descending 270-degree turn to affect the landing. And you have these specific windows that you're trying to hit. So starting with high key, which is, as I said, perpendicular to the intended point of landing overhead that place that you want to land, or the runway if you happen to be at an airport. And then you continue on to low key, which is basically a higher version of a normal downwind. And then you continue your turn, descending turn, all the way down to final. and you can adjust your angle of bank relative to what the requirements are. If the winds are different, whatever the case may be, you adjust that. But the idea is that by repeating this pattern over and over again, you get very familiar with it, so that at any given point, if you intercept that pattern, once you've intercepted it, it's something that's very familiar to you. And that, of course, familiarity breeds confidence and allows you to effectively execute the forced landing. I think it's a great pattern. As I said, the Navy's used it for a long time. The Air Force uses it as well. And I think it's something that the civil aviation community could use as well. So I would encourage you to go out with a safety pilot and fly this particular pattern. Learn what the right altitudes and airspeeds are for your aircraft, and I think it will serve you well in the event that you find yourself in the unfortunate circumstance of losing power in a single-engine aircraft. I hope you've enjoyed this brief overview of my experiences going through naval aviation training. When it was all finished and I was designated a naval aviator, I had about 270 total hours of Navy flight time. And then, as I told you, I went on to SERGRAD, so I served another 1.5 years as an instructor in advanced jet, and then I went to my fleet replacement squadron. In your fleet replacement squadron, where you learn how to fly the specific aircraft that you'll fly in the fleet, you get about another 100 hours or so of flight time. So when you get to the fleet, you're probably just under 400 hours for the typical naval aviator. That may not seem like a lot of hours, but as you can see from what I've shared with you, the training that you receive is pretty extensive. When I was doing the research for this, I actually looked at how the training is conducted today relative to what we did back then. And what I can tell you is it's only gotten better. They're clearly teaching much more in a much more comprehensive way today with much more sophisticated tools than we had back then. And I think that's probably the same for civil aviation as well. Hopefully there's some lessons you can take away from this. I enjoyed speaking with you and hope to see you, as I said, next year.